All right, so this is for Monday, the 8th of February, and you have your cover sheet is available on the front porch. If you don't want to do that, you can go print it out, print a color copy off or a regular copy. But you got to have a cover. If you don't have a cover, you lose like 20 points. So you got to have a cover organization sheet on the front of your packet. All right. And I'll start sharing this screen. And that's you. For everyone else, that's due Thursday for the in-person kids. For you all, it's due on Friday when you come pick up the test. Because you do have to have, I don't like to, unless I just absolutely have to, I don't want to PDF the test. I don't, because these take-home tests, okay, fine. Of course, those are fine. The A test, the 4A, the 5A, the 6A, I'm okay with PDFing those, but not this major test here. So I don't want to PDF it. So in that, you'll need to come by or send somebody by, and unless you're in Chicago or something. I mean, you're going to have to send somebody by for that test. When you come by to get the test, though, at that point, you turn in your notebook and your packet. This is we're talking Friday now, Friday this week. And then you need to, I suppose you can, if you have to, you can PDF me back your test, but actually, no, I want that test. I know we're going to have blue and black issues. That is a weird thing, isn't it? Okay. Here's what we'll do with blue and black. That's black and blue for the test is not till the 24th of February, but I got to think ahead on this. So what you're going to do, I guess, is so you can still have your test with you when you do black and blue, like on the 24th. You're going to pick up a paper copy of the test off the porch Friday, and then you're going to send me. I guess the only way you can do it, I guess, so we can still do black and blue, is you're going to send me a PDF. You're going to take your test, take a picture of it, send me, preferably put it in PDF form, because if you just take a picture and don't convert it to PDF, then it's really hard to read sometimes, and your shadows are bad. And I'm going to have to be forced to print out myself your tests so I can grade it and put partial credit and stuff on it. And then on the 24th, when we go over black and blue, then with the blue pen or green pen, you can fix the problems and then drop by the original test. I originally want that test back. What I'm saying is, instead of dropping it off Saturday, you would send me a PDF. So we'd reverse the thing we did with test 1 and test 4A. We'd reverse it. You'd hang on to the test. That way you don't have to print it off. You know, you would have to take a picture of your completed test, give yourself an hour, and then when you save it as a PDF, and then send that to me. We'll talk more about it. Anyway, that's a little ways away. So here we are, Monday the 8th. This is class number 21. We'll have one more class, really, class 22, and then Wednesdays we'll talk about that. But let's take a look here at the what's coming up. There's last week. This week is test week, and so here's the setup. Now tonight at 9 o'clock, I'm going to do a 9 to 10, an hour-long Zoom, same channel, okay? An hour-long Zoom, and I'll record it, so in case you can't come. But if you want to be able to ask questions, you want to be at the Zoom from 9 to 10 tonight. Okay, if you don't care about asking questions, fine. But then you don't have to go. That's going to help you finish. Hopefully you're at the point where you're finishing up your take-home test. If you're just starting it, okay, just give it a good hard try today and tomorrow. You have till tomorrow midnight, so you have time. You do one page today, one page tomorrow, one side tomorrow if you want. So if you work on it, then you'll have questions at 9 p.m. tonight. If you don't, it's the first time you've looked at it, then I'm glad you're there, but you're not going to know enough to even know questions to ask. So look it over before the help session tonight. I'm not just going to give you answers. I'm going to give you hints. I'm going to help start you off. So tomorrow by midnight, then you do submit that. Take a picture of it. Submit a PDF, preferably. You can practice. And that's just submitted through Canvas, as we've always done. That's by midnight. And then Wednesday, I will post by 8 a.m. It might be before that, but at least by 8 a.m. on Wednesday, I will have the video key for take-home test 4B, where this time it's not just me helping you. This time I'm looking, okay, here's how you work number 1. Here's how you work number 2. Okay, but you've already turned in your take-home test, your best shot. Now, I'm giving you credit on that mostly for effort. Some of it, I will spot check it. But if you wait and turn in your take-home test after the video key's been sent out, then it's a 20% deduction right off the bat. That's 30 points off. Because that's not fair, right? Somebody sits around and waits for the video key and then just copies off the video key. I don't mind you copying onto I want you to, but you should have already turned it in at that point. So you 20% deduction if you do that. So don't turn that one in late. Normally it's 5% a day. This is 20% a day until you've lost, I guess, 40%. All right. So then Thursday in class, we're going to have this test. That's in class. You all, if you want to come, you can come in class and get it over with. Sometimes some of you do. Just come right into class and you take the test. You could take it. You could take it lunch. You could take it at lunch when everybody's gone. My room is pretty empty at lunch on Thursday, so you can come in then. It's pretty safe. I keep the windows open. It's getting cold in there, but we keep the air blowing. And my room is probably one of the safest rooms at Norman High because I have 4 fans and breeze constantly blowing through the room. I mean, I'm almost 62 and I've not gotten COVID, and I've been in that room every day. I haven't missed a day. I ain't even been sick. So I think it's working. We all wear masks. So if you want to just come in and get it over with and not have to hassle with PDFs and all this BS stuff, you can just take it then, either during class, starting at 9 a.m., anytime. Come in anytime, 9 a.m. till the last chance I'll give it will be 12:10. At 12:10, you have to be taking it, okay? Starting it. And I'll give you an hour. We're not going to have, there will be no, on that day, there'll be no virtual. No virtual on that day because we're just taking a test, right? The next day in class is our feast and film. So this will be virtual. This is when the virtual will take the test. So virtual test if you don't want to come in on Thursday, and that's starting at. It'll be available at 1. We're not going to have this. There's no virtual class that day either. So I'll just be coming home. So it took a while to clean up. There's a big mess after feast and film. So it'll be, let's say, available at 1 p.m. on my front porch. Okay, we'll go over this again, but so available by 1 p.m. on front porch. And then for you, this is due. Test is due. I'll formally put this on here. Test for virtual is due by 6 p.m. Saturday. Back on my porch. No. We just changed that. That's PDF sent to me. PDF. I mean, if you want to turn in your paper copy, okay, but PDF sent by sent by 6 p.m. Okay. Whew, complicated. It wouldn't be so complicated if we didn't have to use paper pencil, so because you can get partial credit. If it was all just multiple choice, that'd be easy, right? But then you couldn't get partial credit and people would flunk. So that's the problem. Partial credit's a problem. The other problem is black and blue. Now we got another complication. Things that we do in class that's not complicated at all, but for you all it is. Okay. Then finally, the 2 weeks after this week, tell you the truth, I haven't hardly thought about anything after Pkt4 test. That's where all my focus is on this Thursday. So all I know is we start Pkt5 on Monday. I don't know anything else. Well, I do know that we'll do a flex day on the if we continue on flex days. Big if. I think we have on Wednesday, but I don't know about after that. But if it holds and we keep doing it, then the 24th would be the day you get points back, black problems, blue problems on test number 4.
Mr. Ashby.
Yes.
So when we take test 4B, will Pkt5 be available at the front porch already?
Nope. I'm working on Pkt5. I don't see me. I mean, yes, I've got what I think Pkt5 is, but I need to think through that some more. I know that would be convenient for you if you could just come by and do them. That makes one trip to the porch. I mean, I'll take it under advisement. Actually, tell you the truth, that's a great idea. I'm going to give you two points for that, because that I don't have it ready today, but there's no reason why I couldn't have it ready by Saturday. Okay, and so I'm going to add to that. That'll be a good, more bang for your buck. You'll pick up Pkt5. Ooh, I hope. Because that's the thing is, it's going to be copied off. I'll have it ready to go. I'll have it printed off. I'll have PDFs of everything. Question mark. I'll try. Okay, I'll let you know. I'll know more Friday. When you pick up the test, I'll know if I'll have, because by then I will have had it copied off or not. But that is something that's a goal for me to get. I mean, I got to get it done anyway, right? I might as well. So good thought.
Mr. Rasky?
Yeah.
When will our test 4A grades come in?
Oh, okay, good. Another good thing. So I put everybody's test. I put all the in-person kids' test 4A in the Canvas. This is Brandon's. He doesn't mind me showing you this. These are all the virtual kids. So the reason why I held off on you guys is I wanted to give you one last chance. I wanted to remind you one more time that you need to PDF me any blue. I had about 6 kids PDF me their blue day stuff. We did blue day stuff. So you have until, I don't know, 3 o'clock this afternoon or so, because I'm only going to grade these today. I'll say 4 o'clock this afternoon for you to correct. Remember those 3 problems we talked about? This is on the last, look up the last Zoom meet, the last one we did on Friday. And this gives you the detailed instructions of how to do that. But you got to PDF me your corrections by, let's say, 4 p.m. today. And then this evening, I'm going to go through and grade yours, and I'll so yours will be on Canvas tonight. That's 150 points. Okay. Which will be blown away by the 550 points coming up at the end of this week. All right, that's a lot of housekeeping. Sorry about that. A couple of other things on the packet organizer. Notice that it's worth 125 points. And I'll grade that. And then the notes are worth 75. And then the dogs, this is not virtual. This is not virtual. You guys don't do that. In-class students only. So just ignore that. I'll make sure that you have because you gave me 3 papers. I'll make sure that I'll adjust those scores to make it add up so you have the same amount of points as the other kids do. Okay. And then, so you add that all together though, and you add your virtual stuff you've already turned in, it's going to end up being 250 points for the packet, 300 points for the big test, 150 points for the take home. So it all adds up to a lot of points, plus 150 points for 4A. So we're talking, by the time we're all said and done, what, 300, 400, 700 points, somewhere in there by the time this week. It's going to take me a while to get it all in the grade book, but by the time all the dust settles, we'll be around 700 points. There's only three, this only happens 3 times a semester. So also remember that all the keys are on the Facebook group to these worksheets. So if you're having trouble, so far I've got all the keys up through 4.9. Today I'll post 4.10. This evening I'll post that key. Then tomorrow night I'll post the key to 4.11. And then that'll be all keys. You'll also turn in a paper copy of your take-home test. We'll attach that to the end. So you'll get, some of you never did pick up your packet too. They'll still sit on the front porch. But you'll turn all that in to me Friday. When you come to pick up your test, you'll turn in your packet. Okay. All right. Now we're done with housekeeping. So I went around, gave dogs for 410. Sorry. Oh, there we go. Now, I want you to do this. We set them to the board, and on the test, on test 4B, the rule is that 90% of the problems have to come from the take-home test. I mean, been kind of moved around, some numbers changed, slightly different situation, but basically from the take-home test. But 10%, which equates to 30 points, I can make a surprise. Well, here's a possible surprise, I'm telling you. But here's a possible problem that I'm working on. I thought, well, I'll just show them what I got so far. So here, I made them go to the board on this. And first I was looking at me like, what the heck's going on? So I said, okay, I'll make it a little easier. I'm not saying I'll do this on the test, but I'll make it a little easier. I'll give you a pool. A pool meaning this is what you choose from. Oh, it shut down. It's shutting down again. It does this randomly, just shuts down. You understand that? Anyway, so you're going to write this down, and I want you to, I'm going to put this on pause, and I want you to, we're going to close out again. It's going to close me out. Nothing I can do about it. Okay, I'll start up again. So put this on, I'm going to put it on pause, and you're going to work this. So pause. All right, so we're back on air, and now we're going to, hopefully you're checking your work. I work my way right to left because, okay, here's the deal. That's T to the first, right? And this time, and that's T to the first. The powers are going up by 1. That's nice because the pattern remains. So that would be V naught, the next one up. That would be A naught, but it's 1/2 A naught. Always the first time your coefficient's 1/2. And that would be J naught, and that's 1/6. So that should look familiar. That's the first pink equation. Well, that reminds me, I have a new equation sheet I'm going to put out. I'll try and finish it tonight. I'll put it out tomorrow. So you're going to have 9 equation sheets now available for you to use on the test. That's all legal. Down here we have A naught, then above A naught. Would be okay, for the symbols, I say above, I should be saying below, because then that's J naught, and then after J naught comes S naught, snap naught, but that's, and then the first coefficient's always 1/2. But let me see, I didn't do this today in class. That's as far as we got in class. Let me try something else with you, because this is being recorded. Let's try something else. Suppose it was, let's make it a little harder. Suppose it was V, okay, V of T, and we had box, T, Q, yeah, T cubed plus box, T plus box. Aha, now do that one. what if I gave you a pool? It'd be pretty obvious. I'm going to give you a pool. Let's see if you can get it. I'll pause it again for a second. Okay, so this guy then would be, go different colors, go blue, I guess, so purple. So this guy would be V naught, all right. And then now the question is, well, it's the next one up, right? It's T. So V naught, this must be A naught. And then that's always the first time you see a, oh, I messed up. Sorry, I just made that up. That's not going to have anything with it. Whoa, that's crazy. Oh, wonderful. Okay, so that's not going to have anything with it, right? You guys should have said something, because on the A naught, you don't have that. You do when you get to the squared, then you have a. Okay, so for a cube though, so we missed the 1/2 because the 1/2 went with the square, but there was no t squared. That's t. It jumped from t to the first to t cubed, and so that means that the coefficient order, the coefficients always go like this: 0, then the next coefficient's 1, then it's 1/2, then it's 1/6, then it's 1/24. Okay, so this would be the 0 coefficient, the 1. You could put a 1 in there, I guess. Then the half we skipped, so this must jump to 1/6 then. And then as far as the then it's V naught, A naught, J naught. This must be snap naught. Snap naught, because the J naught we skipped. I don't know if you guys are ready for that, or if the in-person kids are ready. Maybe I'll try. I may try this on tomorrow, just see what happens, and just see how they do. So that could be on the test. I don't know. I'm wait and see on that one, and see how tomorrow goes. But certainly this, where you're just kind of following the pattern and everything's all nice. It's all the powers are nice and neat. 1, 2, 3, 4. You should see the pattern there. I don't know. The purple may be a bridge too far. Let's keep going. And there it is in action. That's kind of this is a takeoff of what we did, Friday. That's from us on Friday. And I put this little thing out. I like this. I think if I ever write a book, this will be a page. Constants have units and are situational. Coefficients are unitless and are eternal truths. So coefficients you can always count on. Constants, who could be anything, 3, 4, 5. But for coefficients, you know what those are going to be. There's the homework. This is actually what we did in class. This is us, what we did in class on Friday. And then I went around and checked the homework. And to keep up with class, you should have done the back of 410. Well, here's the answers to the back. And I'll post this key tonight. But one of the big things from this is this point of inflection. And this POI, it's going to be involved in question number 9 on the take-home test, and also question number 12 on the take-home test. But here's the point of inflection is that point on the X versus T graph that is the steepest slope, the most amount of change. Well, that translates on these graphs aren't lined up, but that translates to the same time on the V versus T graph, where you're at a minimum or a maximum. That's maximum positive slope or maximum remember, this graph here is the slope. This is the slope graph. This is the slope graph of the graph above. So where this thing is maximum, that's maximum positive slope. If it happened to be a minimum down here, that'd be the maximum negative slope. Then point of inflection on an A versus T graph is always 0, because it's always going from either positive acceleration to negative acceleration, or negative acceleration to positive acceleration. But it's where that acceleration is 0. Velocity is maxed out. Your velocity is change, and it's maxed out. Okay, so I want to point that out. And then I'll post this key. You can take a look at it later on. Now we get to why we're here today, which is 411. Okay, we're gonna spend the rest of the time on 411. We got 22 minutes. It'll take us all 22 minutes. We're not gonna finish 411. It's a very hard worksheet actually. So we'll start off with this. This is homework 1 and 2. That's your last homework. For the students, they get 3 dogs out of this. So, you know, it's worth something. For you, it's too late to have you submit it. So, I'm gonna have to grade your packets separately or something. I don't know. There's just slightly different ways of teaching. It's the same material, but it's okay. We'll figure it out. But you just do it. I'll deal with the point system. Okay, so first let's talk about this homework. Now I showed them in class, and I'll show a picture of it. I think I have a video of it too. So I'll put a note to myself to show, and I'll post this in the Facebook. I'll show a video or a pic, at least a pic, of an inertial balance. And it's this thing, it's horizontal, and you pull, it's got these 2 pieces of metal, and you pull it back, and it goes back and forth, you know, like this, horizontally. It's called an inertial balance because it doesn't rely on gravity. Gravity is not really what's causing it. It's this 2 pieces of metal that are trying to get back to the original shape. And so you put weights in there. The more weights you put in there, the slower it goes because it's, you know, because of inertia. Harder to get the thing to change directions. So that's what this first one is. It says, plot 8 seconds worth of a damped oscillations of an inertial balance with 500-gram weight attached, assuming a frequency of a frequency. Didn't say angular frequency. It said frequency of a quarter. It's gonna stop me again. Unbelievable. I don't know what it's doing. It's a corrupted file, so it just kind of has a mind of its own. I have no idea what is going on. All right, back to business. So a quarter hertz. I just downloaded it somewhere. A quarter hertz is 1/4 of a cycle per second. Okay. That's what a quarter hertz means. Hertz is cycles per second. So it's 1/4 of a cycle per second. Just keep that in mind. You're supposed to plot 8 seconds worth. So it's 1/4 of a cycle per second. It looks like in 8 seconds, you're going to get 2 cycles. So you'll have 2 cycles of this. You're going to plot 2 cycles. There's the equation for your damping envelope. So let's assume that A max, maximum amplitude, is going to be 10 centimeters. Okay, and then it's going to drop off. You plug into that formula to figure out what your final envelope is. So you're going to have this dashed envelopes, okay, on either side. That's all I'll say about that because it's homework. Number 2, it says you're supposed to plot an undamped simple harmonic oscillator, and this time the equation is this. So it looks like your amplitude is 20 centimeters. This time it's not going to change. So your amplitude is 20 centimeters. It'll stay constant. And then time the omega is 64. Omega is 64 pi. So from there you can find TP. Remember, TP is 2 pi over omega, so 2 pi over 64 pi. And it says you're only going to plot 1/8 of a second worth, 1/8 of a second. So really fast. It's a really fast oscillator. And so I'll let you do that. If it's 1/8 of a second, you're plotting, and it looks like if I divide this out, that's 1/32 worth. That means that TP is 1/32 because the pi's cancel. So TP is 1/32. The period's 1/32 of a second, and you're supposed to do 1/8 worth That sounds to me like 4 periods because 8 goes into 32 4 times. So basically you're going to have 4 periods there. I'll say that much. That's your hint. That's the most hints I gave them. Now, down to these. Here's what we want to talk about, though, the rest of the time for my next 17 minutes. We'll talk about this. Okay. This is the hardest worksheet, by the way. That was the warm-up app. All right. And I'm just touching on this. Mr. Pentecost came in today at lunch. He was grabbing some spoons and looked at the board. I had this up there. He goes, whoa, you're doing this kind of? I said, yeah. Because he does it in AP physics. He said, well, that's good. That's good. That's a good introduction. That's all we're doing, introduction. All right, so here we have a 500 gram mass, and I demonstrated this. We have a 500 gram mass that's hanging from, I have a pendulum there in class. So this mass is hanging from the pendulum, and I pulled it back and let it go. And then it goes back and forth. Now, this is a 2 meter string. The string is attached to the ceiling. It's pulled from equilibrium, and its vertical angle of pi/6. That is just 30 degrees. And so the mass let go, and the pendulum swings back and forth, no damping. So the first graph we're going to do, and we'll get started on this. We'll finish it tomorrow. Nobody finished this in class. The first graph we're going to do is going to be the angle versus time, the angle that it's going through. Well, it said it started off at pi/6. So my first angle is pi/6, which is 30 degrees. And then we're supposed to plot, I gave you the omega. There's the omega. Omega is 0.7 pi time, inverse seconds. Okay. And you're supposed to, the mass of the pendulum swings rate of, okay, plot for 3 complete sets. So we need 3 complete swings. 3 complete swings. Well, I can plot it and then figure out the time later. Well, if it's 3 complete swings, I'm going to end up back where I was once, twice, 3 times. It's a pendulum. Pendulums have to be cosine, right? You can't have a pendulum that's sine is like this. It just hangs straight down. You need to give a pendulum some amplitude first, then it'll go back and forth, okay? So it can't start off in its ground state. So it starts off in its excited state, and it goes, then it comes back to this side, and then back again, and then back again. All right, so now plot that, and I'll get the details here in a minute. You can get the shape sometimes, without ever doing details. You're going to get as many points as you can on these problems. Okay, so there's my oscillation, assuming no damping. But I got the amplitude, that's negative pi/6 down there. But now I got to get this period, and if omega is that, then TP equals 2 pi over omega. So 2 pi over 0.7 pi. So the pi's cancel. I'm left with 2 over 0.7, which is about 2.8. So that means that this let's go ahead and fill in my times then. This first time is 2.8 seconds. These are all seconds. The next time is 2.8 plus 2.8, 5.6. And the next time is 5.6 plus 2.8, 8.4. And once you have your time, once you have your amplitude, it's not damped, that's it. You're done. So that wasn't hard. Now let's do it again. And this time, we're going to pull that back. We pull the string back, as I did. Then I took a ruler, a meter stick, and I measured, or I was showing them how you can measure. Because I don't really have it set up the way it says here. We are going to hang a pendulum from the ceiling when we do it. We talk about energy, but I just had a regular pendulum. And so you pull this back, and then you're measuring this component, if you can see me, this component of the triangle. That's the X part. So I'll just draw it.
Mr.
So,
Esky,
yeah.
what about the equation?
Oh, sorry. Good point. Let's knock off the equation here. There's no damping, so the equation is pretty easy. So we have on the equation, we have we have this is theta. So theta of t, it's a it's a function of time. The angle's changing. Theta of t is initial theta, which is pi over 6 times cosine, and then omega is 0.7 pi inverse seconds. I'm going to be lazy. Mark that off. 0.7 pi t, and then big bracket, radians, which isn't even a unit. That's it. There's no units. I mean, oh, okay. So there is units. I mean, omega is that ends up being, hold on. Okay. That ends up being inverse seconds, and then that, of course, is seconds. So they cancel. But there are no overall units because degree or radius don't have units. So that's it. So thank you for the question. Now, a point for pointing out that question. Now let's go to this one. And this time, the next three graphs all go together. This is X. This graph will be X dot. This graph will be X double dot. Or V or A. You both mean the same thing. So now we're looking at this pendulum, and this time we're looking at the X component. So if I have let's draw it. So I have a pendulum, okay, and it's there, it's at maximum amplitude. Here's the hardest part of the class today. Maximum amplitude. And then dot, that's equilibrium. So the pendulum's going to go, its direction of motion will be, this way. It's going to end up at ground state right here, right? Well, I need to know this. This is my X. X naught. This is theta. Initially, this is the length of my string. We get a lowercase cursive l, which in our case it said was 2 meters. And this, we said this angle was pi over 6. I'll just do it in degrees. Pi over 6 degrees is 30 radians. 30 degrees, I'm sorry, 30 degrees. So remember this? Oh. 30, 60, 90. So what must this X be? What must, if the hypotenuse is 2 meters, what must X be? X naught. X max. I'm going to say X max instead.
Would it be 1?
Thank you. Now there's the point. 1, because the opposite side of the 30-degree angle is half the hypotenuse. Sine of 30 is 1/2. So X max, better to call that than call it 1. Call it X naught. X max is 1 meter. So my initial over here on my graph, it's going to look just like the green. Just like the green. let's go here, but let me darken that up a little bit. Okay. So just like the green, but so it's going to start at 1. We're going to go 3 oscillations. The only thing that changes is the period's the same. The only thing that changes is the amplitude. And instead of being pi/6 radians, it's going to be 1 meter. So this is now meters. So 1, -1. Okay. And it ends up just a carbon copy of the graph above. Okay. We're doing on time. Good, we still got 7 minutes. Good. We won't finish, but we'll get a lot of this done. As of now, this is still in the test, but so on Thursday. It's on the, this is, by the way, the last question on the take-home test has to do with what we're about to do. Okay, so equation-wise, you know, you're just going to have x of t equals, this time we have 2, I'll be lazy on the units again, 2 cosine 0.7 pi t parentheses, bracket, meters. Okay.
What about the time on the bottom of the graph?
What's what?
What about the time on the bottom of the graph?
Same. The times are the same. It's the same pendulum, so it has the same, you know, periods. In fact, that is true all the way down the page. You can just fill that in all the way down the page. Okay. Now, here's the part that's the hardest part. I saved that for the last 5 minutes. Okay. We're going to punt till tomorrow for the hardest part, but I'm going to talk about this part. When we watched that pendulum in detail in class, we watched it go back and forth. So if you take something and hold it up, you know, simple pendulum like this, like let's say my charging case for my ear pods. Plug that in, and okay, so here, so it goes back and forth, right? That's what we're looking at. Go back and forth. Where the x is maximum on the outsides, what is velocity?
0.
0. And when this is considered 0x, that's considered that's equilibrium. That's 0x. So when the x is 0, what do you know about velocity? I should say, when is this thing going the fastest?
At the sides when it's about to swing again.
Oh no, it's not moving at that point. There is no velocity at the ends. Where is it going the fastest?
At the very bottom.
Right, at ground state, when x is 0. So keep that in mind. And then let's at least try and plot in the time we have x versus t. So now v versus t. So now another way to look at it is this. Look, this I wish and there are students who are in calculus right now, and I said, was this explained this way to you? I said, no, we just memorized it. Well, daggone it. Come on, math. If this had been explained to me this way, I would have got it a lot better. But notice that the slope, the tangent line there, the slope is 0. And then as that goes down, it gets steeper and steeper until you reach the equilibrium, until you reach the point of inflection, which is right there, inflection point. And that it's the steepest, the tangent line is, which is the slope. And then the slope kind of starts to level off again and becomes less and less steep.
So is that when the object's at the bottom of its swing?
Yeah,
Point of inflection?
okay, right. Okay, so at equilibrium, that object's at the bottom of the string of its path. So that's this right here stands for equilibrium. This little point right there. I mean, you could spend an entire semester, in fact, you will in college, just talking about this stuff. So I'm just introducing it to you now. But on the velocity versus time, notice that velocity is measuring the slope of the line. So my initial velocity, the slope is 0 right there. And that's because it's not moving. It's not moving on the end. So yes, this is v versus t. So velocity is 0. But then notice, look how steep right here. Come on, man, don't buffer. Right here. Right here. Here. Notice how steep it is. That's maximum speed, because steepness equals speed. So maximum speed at equilibrium. So that means that on this graph down here, I'm at maximum negative speed. Right there. This is let's see, that was back here. Hold on. That's right there. And then this is halfway. Okay, it's right there. Yeah. So that's maximum negative speed when the object is equilibrium. The velocity's maximum negative. And when the thing swings back to the other side, velocity is 0. So this is also this is a cosine. Sorry, it's a sine wave. But it's a negative sine wave. You see that? So anytime, last thing here, anytime you have cosine for the x, if it's generally a cosine function, the derivative of that is always going to be negative sine. And I wish somebody had told me that in high school. I barely learned that. I was probably a sophomore in college before I found it, and I had to figure it out myself. Nobody ever told me. Would have made things easier. So that's because I just said, well, the derivative of cosine is negative sine. And I knew that because somebody told me. And let's finish this up. Last thing. So here, notice the slope here is 0. This is now a positive point of inflection. Puts me up here. And so I can just, all I'm doing is I'm completing the sine wave. And you can do that again for the next part. Now, tomorrow's when it gets hard. It's one of the hardest things we do all year is tomorrow. The last day of the packet. I saved the best for last. But we'll leave you in suspense on that one. That's tomorrow. That's good enough for today. I've given you a headache already, so we'll pick it up there tomorrow. Okay? Stop this. Stop the sharing. Okay. So tonight, sometime tonight, you'll see your grade posted, the final grade posted on your test 4A. That includes any blue work. You're going to PDF me. Remember, the PDF is number 2, number 2, number 9, number 7, and number 5. 2, 5, 7, 9. Those are the 4 you can redo. And there's a key posted, by the way. Yeah, we went over it, and so there's a key posted on when was it? Wednesday last week. Yeah. So anyway, see you guys. See you tomorrow. Have a good Monday, everybody.